Okay, let's look at the concept of upthrust. So we are still under density and relative density, but let's look at upthrust. So from what I've written here, I said upthrust is a force which pushes upwards on an object submerged in a fluid, and the fluid is either a liquid or a gas. This force is also known as buoyancy force. So even aside that, in our everyday life, if you put a bucket of water while holding the handle into a very big tank or filled with water, and you want to use that bucket of water to fetch some water from that tank, you will notice that while the bucket is now submerged into that tank filled with water, the bucket will not seem as heavy as it was before you put it in that tank. So, but let's use this simple physics experimental diagram here to explain what I really mean. So, if you look at this diagram closely, I have my spring balance, and my spring balance is used to check the weight of an object. So, this is the object we're going to consider now. So, while the spring balance is in air, so it's in air now. Of course, this second spring balance, the object rather, is in air, and this second spring balance has the object submerged in a particular liquid. So this is now submerged in a liquid. So you will notice that while the object we are considering here is in air, the weight that this spring balance will measure, the heaviness of this, the weight that it will measure is 5,000 Newton. But when it is now submerged into a liquid, the weight of the object has now reduced. This object that was weighing 5,000 Newton while in air, the object is now weighing 3,000 Newton while in a liquid. What does it mean? It means the liquid is exerting a particular force on this object. And since the liquid is exerting an upward force on this object, it is now reducing the weight of the object, the actual weight of the object. It will look as if it's not that heavy because there's a particular force helping you out here. So the force is pulling upward, trying to restrain the object from sinking down into the liquid. So that force that is pushing this thing upward is what you want to consider. Don't forget, every liquid exerts that force on objects that enters into them. So this liquid is actually exerting a force on this particular object because it's inside the liquid. So it will be pushing upward, like trying to restrain it from going further into the liquid. That force is the upthrust. Now, before we see the ways, the two ways by which we can calculate or know the upthrust based on this experiment, let us consider finding the density of this liquid. How do you find the density of this liquid based on this experiment now? So let us look at the way we can find the density of this liquid. We know that the density of this liquid, of course, we are going to use density equals mass over volume to find the density of this liquid. Since we're using density equals mass over volume, where is my mass and where is my volume? Because I need to get the mass and the volume and divide to find the density of this particular liquid. So what I'm going to do is this. How do I get my mass and my volume? Let's start with the volume. Since I want to get the density of this liquid, first of all, I'll start with the volume. And how do I get the volume? I'll actually get the volume of the object that is placed inside the liquid. I'll fix the value for this volume because we're considering that object now. So to get the density of this liquid, now that an object is now immersed into it, we're going to do mass over volume, and the volume will depend on the volume of that object that is being placed into the liquid. Now, the object is not a regular object like your cylinder or your cone, your cuboid or your cube that you can easily use a formula. For cylinder now, you can just use pi r square h to find the volume. Then you just multiply the pi times the r square times the height, and then you fix the answer here. That one is easy. But now this object is irregular. It doesn't look like any shape that you can calculate. So since it doesn't look like a shape you can calculate, there's a way out for you to get the volume of this object that is in this liquid. So how do you get the volume of this object that is in the liquid that you cannot calculate? You consider the displacement of the liquid when this object is placed inside. Okay, let's imagine before you place this object inside this liquid, look at the volume of the liquid here. It's just 50 centimeter cube. When you now place the object into the liquid, the volume of the liquid now increased to 70 centimeter cube. It has been displaced from the 50 centimeter cube mark to the 70 centimeter cube mark. That is how we can get the volume of this irregular solid without doing much calculation or without finding a direct formula for that particular object. So how do you get the volume of this liquid now? Of this object rather, you will just subtract the new gauge minus the old gauge. You just say 70 centimeter cube minus 50, and then you get 20 centimeter cubes. Once you can get that, it means you have actually found the volume of this irregular solid. It's as simple as that. Very easy. You just subtract this new gauge minus the old one. It works all the time. Even if you have another cylinder again, and this is the water level. Let's say they are using water this time, this 10 centimeter cube, and we have another irregular solid we want to get the volume of. Then this is the second graduated cylinder. Then you now fix this one inside, and the water level now increased again. See it inside, it's now inside the water. The water level now increased again to 30 centimeter, or let's say 40 centimeter cube. In this case, since you know that this object is so irregular that you cannot even get a formula for it, you can use this experiment to find the volume of this solid. You just say 40 minus this 10 now gives you 30 centimeter cube. That means automatically the volume of this solid, based on how the liquid increased from 10 to 40, the volume is now 30 centimeter cube. That's the trick. So that's what we used here. So we now fix the volume here as 20 centimeter cube. It's not just by fixing the volume there. You are going to pour out that volume. So that 20 centimeter cube of water, of this liquid rather, you can pour it out somewhere, like in a beaker. Just pour it out somewhere in a beaker. Let's say it's a beaker. So the 20 centimeter cube difference between this and this, just pour that 20 centimeter cube out in a beaker. When you pour it out, you now put that beaker on a balance to find the mass of that water. If you bring that same 20 centimeter cube you used as the volume here, because I'm trying to get the density now of this liquid. Remember, the density of this liquid will depend on the volume of this object in the liquid and the heaviness of the same liquid. How did I get the volume? I just did 70 because the liquid went up a bit, and I did 70 minus 50. I got 20. Then that same 20, pour it into this particular beaker. Then measure the mass. Measure the mass of that particular liquid. When you measure the mass, write the value of the mass for your M here. So it all depends on the volume of the solid inside this particular liquid. You know how we got it? Don't forget, there was no direct formula for us. I had to subtract. So when you now measure it, pour the 20 centimeter cube inside this beaker and weigh it with a balance, then you will now get the value, the mass of that liquid in kilogram, because you just weighed it. Check the mass, then you fix here. When you fix the value for your M, you now divide that value by this 20 centimeter cube. You get the density of that particular liquid. So that's one thing you should take note of. Now, this mass that you even get, if you multiply it by acceleration due to gravity, G, you are actually getting the force or the weight, the force that the liquid is exerting on the object. So let us now consider the upthrust now. So what's the first you're finding the upthrust? This is the first diagram. You can say the upthrust can be gotten by subtracting the weight of the object in air, by saying the weight of the object in air minus the weight of the object in the liquid. That's the first method of finding the upthrust. Weight of the object in air minus the weight of the object in the liquid. Now that means our upthrust, or the force that is actually pushing this object up. The upthrust exerted on this object, you just say the weight of the object in air, which is 5,000, minus the weight of the object in the liquid, which is 3,000. So you just say 5,000 Newton minus 3,000 Newton is going to give me my upthrust, which will be 2,000 Newton. So that's this. This is the first method of finding your upthrust. If you can know the weight of the object while in air, and you now know the weight of the object while in the liquid, the weight of the object here is 5,000. The weight of the object here is 3,000 while in the liquid. Just subtract them, you get the upthrust. That's the first method. The second method, method 2 for upthrust, this is method 1. Method 2 is to consider the density of that liquid that the object is in. So density equals to mass over volume. And the upthrust, based on this formula, will depend on the mass of that liquid that is being displaced. Remember I said the density of this liquid is the volume of the liquid, the volume of the object rather, which is gotten by the displacement of the liquid upward by doing 70 minus 50. That's your volume. So let's assume that after doing the mass divided by the volume, that means the weight of this 20, after doing 20 centimeter cube as the volume and dividing by the mass, or doing mass divided by that volume, actually the mass divided by that 20 centimeter cube, you now got the density. Let's assume the density of this liquid is 20, or let's assume it's 10. So 10 kilogram per meter cube is our density. Let's assume the density of this liquid is 10. We want to show you the second way of getting the upthrust. So density equals to mass over the volume. What's the volume? The volume is 20 centimeter cube. Now I got the volume of the object in the liquid by the water displacement. We just did 70 minus the 50. We now got the 20. So I'll put 20 here. But I know that if I weigh this, if I put this 20 centimeter cube of the liquid in a beaker and I measure it, I will get the mass. But I don't want to go through that stress. I want to just make my mass the subject of the formula. So cross multiply. My mass will now be 200 times this 10. So the mass will now be 2,000 kilogram. 2,000 kilogram. 20 times 10 rather, sorry about that. 20 times 10 will give me 200 kilogram. So the mass will now be 200 kilogram. But we have to convert this mass to weight because the upthrust is actually a weight or a force. So it has to be in Newton. And how do you convert something that is in mass to Newton? You multiply it by the acceleration due to gravity, which is mostly 10 or 9.8. So I'll just say my upthrust now will now be 200 times 10, which is now 2,000 Newton. 200 times 10, which is now 2,000 Newton. So what did you notice about this second method? That the upthrust can be gotten from the mass of the liquid displaced. If you can get the mass of the liquid displaced, you have actually gotten your upthrust because you just convert the mass to weight by multiplying by 10. That is your